Okay, good news is about 6 to 8 of y'all have taken tests, and it seems like y'all did pretty good on it. That's the good news. The bad news is there's about 6 or 8 of you that, when I say haven't done the homework, I mean literally it looks like you haven't done any of the homework. I'm not going to lecture, but I don't understand that. I'm not talking about students that have 2 or 3 sections missing. I'm talking about 3.3 through 3.11. There's nothing. So I don't know what's up with that. Maybe that's some kind of new math that y'all are doing. I don't know. Called Tide Pod math. I don't know, but I don't think it's going to work. But you go ahead and do what you want to do. The ones that have a few sections missing, I'm not talking about y'all. Y'all are just, working on it and trying to get it done. Got some questions to go over. Most of the questions that y'all are sending me and the 140.01 sent me, they're all questions except for a few that are just, I don't know where this book gets them. Have y'all noticed that this book just gets questions, I don't know where they're from? Does any of y'all notice that? Okay, I just want to make sure I'm not the only one. In fact, there's one question. I'm going to go ahead and find it right now. Hold on just a second. Let me find it. I had to do it for the last class. There it is. I'm going to start class with this question because, like I say, I've been teaching for a long time. And some of the stuff that they're putting out, I have no idea where they got it. Let me see if I got a number on this one. Nope. But I remember it's Mr. Smith from the other class, so let me find it right quick. We're going to do the other ones, but I just want to, yeah, there it is. The question, we got a new email. I don't know if y'all's email has changed, but our new email, the Outlook email has changed, and I'm not used to it. So y'all have to bear with me. It just changed today. This question is 3.77 or 3.379/23. Now, the reason I'm showing you this question is I'm just telling you, this is no joke. I've been teaching calculus probably for about 12, 15 years. And I've never seen what I had to research this question. Have y'all seen this question? I had to actually research to find out how to do this question. Now, I'm not raising my hand and saying I'm a dumbass. What I'm raising my hand and saying is, I don't know where this comes from. Okay, I really don't. I'll be honest with you. I don't know where it came from, but it's called straight line differentiation. Now, let me ask y'all, how many of you have had just raise your real hand. How many of you have had a calculus class or pre-calculus before this class? Okay, have any of you seen this before? Now, you think it's the slope. It's not. Look at it. Now, those people that raised their hands a while ago, how many of you have seen this before? Okay, Miss Seiler, you've seen straight line differentiation before?
I remember seeing that format at some point, but I've never seen a question. I've never seen it applied to a question like that.
I think you've seen it as slope, haven't you?
Maybe. But like
I've never seen this.
remember
I've
I
never
remember
seen
that
this before.
vaguely at some point.
And I took Advanced Calculus 1 and Advanced Calculus 2 at Clemson, and I've never seen this before. So I'm going to find out where they're getting some of this stuff. I don't know where they're getting it. And the only other thing that comes with it is whenever you see one of these questions that are from left field, what else do you notice about it? It just has ask, it don't have ask my instructor, it has what? Ask the publisher. So I don't know where these questions are coming from. But here's one question. I'm going to do it for you. And in fact, how did you send it? If it only says print and ask the publisher, how do you send it to me?
Well, you are the instructor, right? So you wouldn't have asked the instructor on yours.
Well, I'm
just guessing. I don't know.
I don't understand it. But anyway, you've got to use this formula right here. So I want you to take a minute, and I want you, and the only reason I'm showing you this is because now I'll also show you another way to do it, and you'll be like, oh, that's a whole lot easier. So I don't know where this comes from. So anyway, to make a long story short, go ahead and write that down. And this is called straight line differentiation. Okay. So what I'm going to do off of this graph right here is I'm going to pick 2 points off the f of x, and I'm going to pick 2 points off the g of x. You can pick any 2 points you want, but I'm going to pick, and for the class's sake, let's just pick 2 points. So I'm going to pick, let me get my black pen. I'm going to pick from f of x, I'm going to pick 1 and 7 and 4 and 1. And for g of x, I went through and picked these points before class. 2 and 4 and 4 and 6. And now I want you to do this. This is x of 1, this is y sub 1, this is x sub 2, this is y sub 2, x sub 1, y sub 1, x sub 2, y sub 2. Now me, I don't understand why they just don't do find the slope and find the equation. But for some reason, they're wanting you to use this. See, I could go through right now, and I could do m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And that's negative 6 over 4 minus 1 is what? 3. And that's negative 2. Y minus 7 is equal to negative 2 times x minus 1. Y minus 7 is equal to negative 2x plus 2. Bring the 7 over. Y is equal to negative 2x plus 9. Does everybody see that? That's what you did back in Algebra 1, Algebra 2. And there, for some reason, they're going, okay, I want y'all to use this straight line differentiation. So I'll do g of x the other way. Y'all do it this way. See if you get negative 2x plus 9. Plug and chug. I'm going to do g of x this way. So that means y minus 4 over 6 minus 4 is equal to x minus 2 over 4 minus 2. And that's going to give you y minus 4 over 2 equals x minus 2 over 2. 2y minus 4 is equal to 2x minus 2. 2y minus 8 is equal to 2x minus 4. 2y equals negative 2x minus 4 plus 8. 2y is equal to negative 2x plus 4. Y is equal to negative 1x plus 2. Okay, y'all check me, see what y'all get. Over here, I found the slope first, and then I used this point, and I found the equation of the line, like everybody in this class has been doing since the 7th or 8th grade. Over here, we're using this that just come out of the blue. No, it didn't come out of the blue. Hubert had to research it and find it.
That's one of them common core tactics.
Yeah, I think it's something. I don't know. I really don't know. Okay, did y'all get negative 2x plus 9 and negative x plus 2? I need somebody to say either yes or no.
Yes.
Okay, I got one person that says yeah. All right, so I'm going to take my orange pen, and I'm going to take the derivative of this. Y prime is equal to negative 2, and y prime is equal to negative 1. Now, the question says, let G equal 6F minus G. Let G equal 6F minus G. And then it says find G prime of 2. So that means I've got to take G, I got to take this prime, so that's going to be G prime is equal to 6F prime minus G prime. Well, it doesn't matter. Whatever you plug in, you're going to get negative 2 because there's not an x right here for your y prime. So you can plug in G of 3, G of 4, G of 5, still going to be negative 2. And you can plug in all day long over here, G of 5, G of 6, you're still going to get a negative 1. So you take those two derivatives and you plug in to 6 times negative 2 minus negative 1.
Isn't the derivative, wouldn't the derivative be different based on which side of the equation that you're on, since it's an absolute value equation?
I'm sorry, 1. F prime. F prime is right here. There's F prime. F prime of X. G prime of X is -1. So whatever I get for F prime, I don't care what I plug in. I don't care what I plug in, it's going to be -2. Whatever I plug in for G is going to be -1. So it really doesn't matter what I plug in. This right here doesn't matter, because there's no X right here. There's no X right here. Just a number. So whatever I plug in to G prime of, or F prime of X, I'm going to get -2. Whatever I plug in to G prime of X, I'm going to get -1. So that goes -2 goes right there. -1 goes right here, or 1, +1 goes right here. And the answer comes out to be 13. Like I said before I started the question, where this question comes from, I have no idea. Is it relevant to your test? Hell to the no. Is it relevant for you understanding derivatives? Hell to the no. I have no idea where this question comes from. Is it a stupid ass question? Yes. Not that somebody sent it. It's a misplaced question. I don't understand why it's even in this homework. If I knew it was in this homework, I would have took it out. So I'm sorry about that.
See, I remember straight line differentiation from high school. I don't know why I was doing it in high school, but I would have never thought to apply it to that problem.
Well, I have never seen it. And that's what makes me feel if you say you've seen it, that makes me feel like it's something new that I've never seen before. Like you said, I think it was Mr. Paris that said some of this new stuff is Tide Pod math. I think it's some of that Tide Pod math. What'd you call it, Mr. Paris?
I'm a little bit before the Tide Pod math, but I believe it's called Common Core. Is it not Common Core math or something like that?
I think it is too. All right, so let's move on. I'd like to cover some decent questions. Let's see, what do we get? We got -13. There you go. All right, let me go up here and pull this one. This is 310, 37, 14. 310, 37, 14. This one's okay. It's not a bad question. This one ain't like the last. This one isn't like the last one. First of all, we got f of x is equal to 2 cosecant -1 tangent of e to the x. And they want the derivative. So we go to our handy dandy. First of all, we don't even write anything down. We go to our files. And we go to our inverse trig functions. And the reason I'm pulling this up with you is I want you to see that that's the first thing you should do. When you see this problem, you go to your derivatives of inverse trig functions. And we want the derivative of the cosecant. So we're going to write this down. I'm going to write it down in red, or a pigment of red. D of dx of cosecant negative 1 of x is equal to negative 1 over the absolute value of x square root of x squared minus 1. And of course, you can't take the square root, you can't have 0 in the denominator, and that's why you got x cannot equal positive or negative 1 or 0. Okay, so we go back here. And that's the first thing you should do, is write down the derivative of the inverse cosecant. There it is, right here. Now your x is right here. 2 cosecant negative 1 of x. Right there. There's your x right there.
What problem did you say this was?
31037/14. So we're going to need the derivative of the tangent, and we're going to need the derivative of what? E to the x. Now, if I change this to 2x, then we would do e to the 2x times 2. But since it's e to the x, they're being easy with us. So I'm going to go over here in orange. I'm still working to the side. D dx of tan is equal to secant squared. And d dx of e to the x is what? E to the x. Okay, so now we just take the derivative of this, be 2, and then we'd write down all of this trash, and then brackets, because this is this right here. And it'd be the tan, it'd be all of this. And then, like I said, the x is the tan of the x, so you're going to plug that in right here and right here. So let's go to it. So we're going to put a big equal sign, this equal sign right here. We're going to put it right there. And that 1 and that cosecant, that's all going, that 2 is going to go with that negative 1. And then secant squared. And e to the x. No, secant of e to the x, sorry. All that goes there. And then on the bottom, my x is what? Tangent of e to the x. So that's going to be tangent of e to the x. Square root tangent e to the x squared minus 1. And guess what? You're done. Now, of course, you can take this e to the x and put it with that negative 2 right here. You clean it up a little bit. Now, what I'm going to do is I'm going to take this right here. I'm going to make sure you understand that that tan e to the x is your x. You got to realize that, because that goes in these two spots right here. And that negative 1, that's right there. Remember me telling you that inverse derivatives of trig functions is plug and chug? And I told you that you're going to see it in Calc 2 and 3, plugging and chugging. This is a prime example. You don't do much thinking. You just do what? Take the derivative and you plug and what? Plug and chug. The more advanced you get with the calculus, the more you're going to see the plugging and chugging. All right. So I'm not going to type all that in. It's going to be negative 2 e to the x secant squared of e to the x over tangent squared minus 1. But I'm going to let y'all see it. Negative 2 e to the x, that's right. Secant squared, yep. And you can write that secant squared. You can put the square on the outside, or you can put it right here. It doesn't matter. Over tan squared minus 1. That could be a test question, but the only reason I put it on the test is so you can just plug and chug. It's not meant to be 15 parts. As you can tell, I did this. This was written on a piece of paper for me that I've printed out for the test. I did this, and then plugged and chugged. So 3 steps. 1, you write down the problem. You take the derivative of the tan, and then you take the derivative of e to the x. Now, what if this was e to the 2x? Then you would have did d dx of 2x is equal to 2, and then that would have been a negative 4 secant squared e to the 2x. Next question. All right, this one, I did one for the class earlier. This is 3.10, and I'm just going to do this one because it's a little bit different. 3.1031/12. Y is equal to the inverse cosecant of x to the 10th plus 1, and all numbers have to be positive. Okay, so there's the question. Now, from the last problem, let's go back. The cosecant is equal to this, so write that down again. I'm going to write it over here in red. Again, I'm just trying to get you to understand. What you don't do is freak out whenever you see an inverse cosecant. You go over here to the side and you write down what's on the cheat sheet. Sorry, I keep hitting the wrong buttons. You write down on the cheat sheet that I gave you and sent you d dx of the inverse cosecant is equal to negative 1 over absolute value of x square root of x squared minus 1. And now you determine what x is. Well, here's x. There's x right there. So that x10 plus x to the 10th plus 1, that's going to go in the denominator twice. And then that's pretty much it. So y is equal to negative 1 over that's going to be x to the 10, and I'm going to write down here, I'm going to put let u equal x to the 10 plus 1. Therefore, the derivative of that du or u is equal to 10x to the 9th. So all I did is I took the derivative of what's inside the parentheses, so you can use that later. I just went ahead and took the derivative. Okay, so I'm just doing that over to the side. This is the derivative of what's inside the parentheses. So that's going to be absolute value of x to the 10th plus 1 square root of x, or x to the 10th plus 1 quantity squared minus 1. And then I have to take the derivative of this, which is this. So I'm going to take my orange pen and put that right here. Because I have to take the derivative of what's inside. And it's right there. So your final answer is that. So that's it. So y prime is equal to negative 10 x to the 9th over absolute value of x to the 10th plus 1 square root of x to the 10th plus 1 squared minus 1. Again, this is not to help you with your derivative like power rule and product rule. This is more of getting you in the habit of whenever there's a plug and chug rule with derivatives or antiderivatives, you can use the plug and chug rule. And this is a plug and chug rule right here. Okay. That's 310. That's that one right there. Now, this one. What does this one say? This is 38113. 38113. Hallelujah. This is a good problem. This is a normal calculus problem. All right. X is equal y to the 8th. Is this a test question? Could be. Now, I've done this question several times, and I think the answer is incorrect because I've done another problem like this, and I got it correct, and there's not much difference. I think it was like y is equal to, or x is equal, where is that problem I did? X is equal to y to the 16th. I did that problem and got it right. I did this problem and got it wrong. So I'm going to let y'all find the first and second derivative. Let me see what y'all come out with. But I do think the answer on this problem is wrong. Did somebody in this class send this one?
Matthew Paris sent it.
Mr. Paris, is that why? I bet you got it right, but you say, but it says it's wrong. Correct? Or did you just send it because you were clueless? Okay, that's all right. You don't have to tell me. Hold on just a minute. I'm going to let y'all work on that for just a second. I recently got a Ring camera set up on my mama's house. You know, the Ring cameras that you have, and she's talking to it. I couldn't figure out why she was talking to it. Well, my sister was talking to her on the Ring camera, and that's why she was talking to it. I thought she was losing her mind talking. I didn't know my sister was talking to her. I promise you I'm not drunk, okay? I promise you. Yeah. I do want to show you my son. This morning we got up and he wanted to run the bulldozer. So I let him run the bulldozer. There he is running the bulldozer. I was playing with it. I was making it run fast. But he was pulling up locust trees. Now, before some of y'all start having a fit about us killing trees, do any of y'all know what a locust tree is? Hell no. Okay. A locust tree is a tree that grows and it has about 2-inch spikes on its limbs. Like that long. And you know what those spikes do? They flatten tires. So that's why we're pulling them up. It's kind of like pulling up weeds out of your garden. But ain't he doing a good job there? That's neat. I was proud of him. He did good. 14-year-old and thinking he knows everything. He did good. All right, I'll shut up. All right, here we go. This is a good test question, even though I think the answer is incorrect. So I'm going to take my derivative. This is implicit differentiation. So 1, and get me a new black pen, please, is equal to 8y to the 7th dy dx, and divide by 8y to the 7th. So your first derivative is equal to 1 over 8y to the 7th. Okay, somebody confirm that's what you got.
That's what I got.
Okay, now take the second derivative. So we got to rewrite this as what? 1 y to the negative 7th over 8, or 1/8 y to the negative 7th. All right, I want y'all to take the derivative of this and tell me what you get, because I guarantee you, you're not going to get what they got, because I'm not going to get what they got. I'm going to write it out. Negative 7 times 1/8 y to the negative 7 minus 1 is equal to d2y over dx. Negative 7 over 8 y to the negative 8 equals d squared y over dx. Negative 7 over 8y to the 8 is equal to d squared y over dx. All right, somebody confirm it. Is that what you got? Well, that ain't what they're going to get. They make this into a 64, and I cannot for the life of me figure that out. But all the other problems I did, I got right. So I think the answer is wrong in this problem. And I'll show you why. See what they did? They raised 8 to the second power. I don't understand where they got that. But right quick, before you answer, do this problem. X is equal y to the 16th. Do that one. Find the first and second derivative implicitly. There's my first derivative. All right, I'm going to take the derivative again. I'm going to rewrite this as 1/16 y to the negative 15 is equal to delta y over delta x. So taking the derivative again, that's going to give me d2 dx. And that's going to pull this around. That's going to make this, I'm thinking out loud, negative 15 times 1 over 16 y to the negative 15 minus 1, and d2 over dx is equal to, I'm looking, negative 15/16 y to the negative 16. So that would be negative 15 over 16y to the 16th. Now, we did the same exact thing that we did on the first problem, right? But this one we're going to get right. So that's why I think the problem on the first one is wrong. Unless somebody can see something that I don't see. So let's type this one in. Well, I don't know if this is well, that's the right answer. I don't know where I got this question. Let me hit similar, see if it gives me the same one. No, but we can do this one. Y to the 12th. Let's do this one. See if we get this one wrong. So that's going to be 1 is equal to 12 y to the 11th dy dx, and 1 over 12 y to the 11th is equal to delta y over delta x. So change that to 1 over 12 y to the negative 11th is equal to delta y over delta x. And that's going to be negative 11 over 12 y to the negative 12th equals d2y over d2x. And that's the same thing as negative 11 over 12y to the 12th is equal to delta over. Tell me that's what you got. All right, let's go back and see what the answer is. I'm not going to type all this junk in. I'm just going to. Well, what happened? Hold on, I lost y'all. Let me pull y'all back up. There we go. 3, 3. I don't care about playing their games. I just want their answer. They did it again. I have no idea why they keep multiplying that 144 times 2 or by itself. And the 23. I have no idea why they keep getting that.
Does it have it on a help me solve this when you go to question help?
Well, it'll show you everything we just did, but then it'll get down to the bottom. Y to the 25th, so that'd be 25th, 25, y to the 24th. See it? All right, now I'm going to do the second derivative. 1 over 25, y to the 24th. I'm going to do it. Is equal to delta y over delta x. And that's going to be 1 over 25, y to the negative 24th. So that's going to be negative 24 25ths, y to the negative 25, which is negative 24 over 25, y to the 25th equals the second derivative in respect to y, or dy dx.
So when you write, I have a question. When you write the derivative on the right side of that, and you write d squared or d2y over dx, how come your notation is different from theirs? Because they've got a d2y over dx2.
They just did it a little bit different. Sometimes I put a 2 there, like that. Sometimes I put a 2 there.
Okay.
Isn't that what I got? Y'all look at me. Isn't that what I got?
Yes.
Okay, now they're doing another. What are they doing now?
Substituting the original derivative back in.
Oh, I know what. You know what I'm forgetting? When you take the derivative, you got to put y prime beside it. That's what I'm forgetting. Okay, it's legitimate. I'm crazy. I'm crazy, and I need to just quit today. When you take the derivative of implicit differentiation, when you take the derivative of y, what do you put beside it? dy dx. And when you take the second derivative, you put dy dx right here. Dy dx. And that is this right up here. So now you got to multiply this by that. I'm sorry, I forgot about that. So that'd be negative 24 over, but why did I get the other one right? 25 y to the 25th multiplied by 1 over 25 y to the 24th. And that's going to give us negative 24 over 25 times 25 is what? 625? Y to the 25 be 49. And that's equal to, I can't even write, dx. I know y'all think I'm drunk. And the reason I just forgot when I took the derivative on the left-hand side, I forgot to write my y prime, dy dx. You're supposed to do that all the time. Or y prime, when you take the derivative, you're supposed to put y prime beside it. I've been putting dy dx because of the related rates. And you plug that back in. So you're right, Mr. Paris. Oh, me, oh my. I think after a while you start to go loony doing all this stuff. All right, let's do another problem. And let's do this is one. Let's see, this 3.3. Let's see. I think we did this one, didn't we? Now Mr. Paris is making us dizzy. Yeah, we did that one. 3.7, 111. Okay, this is a question that you can do it, but they've gone around the world to tell you how to get to your own house. Okay? This is not a test question. This is a question I would put on the test because I hate you. Okay? You know how to do it, but you don't know how to do it because of the way they've worded it. Does everybody understand that? Remember the difference quotient? The difference quotient says f of x plus h minus f of x over h. And this is the original function. And this is the function that you plug in x plus h. Okay? So does everybody remember that? Hopefully you do. This right here, it looks like to me, since this is squared, this says cosine of pi over 2 plus h squared minus cosine of pi squared over 4 over h. Now I want you to ignore the question because the question is very misleading. I want somebody to tell me what x is. Just look at this and tell me what x is.
Pi over 2.
Hosts.
X is equal to pi over 2. Then tell me what the function is equal to.
Cosine of x squared.
F of x is equal to cosine of x squared. That is how you do this problem. Okay, a lot of people are saying, wait a minute. Well, this is x plus h, isn't it? Isn't that x plus h? So therefore, x is equal to pi over 2.
So where does the
So
pi
that
over?
would make sense, because look at here. What is x squared? Pi squared over 4. So that means that the function is the cosine of something raised to the what? Second power. Now you can do what they ask you to do. So when you see one of these questions, kind of ignore their wording and just go in and find x and find the function. So what is g of x? That should be the cosine of x squared, isn't it? Cosine of x raised to the second power. A is equal to pi over x is equal to pi over 2. Look at that. Now somebody tell me what the derivative, let's go back over here. What is the derivative of the cosine?
Negative sign.
Negative sine of x squared. And somebody tell me what the derivative of x squared is.
2x.
2x will go out front. Negative 2x sine of x squared. I'm just going to put a 3 there. Now, they may put the pi over 2 in for x, but I'm not worried about that. And they put the, they went ahead and plugged in the pi over 2, and that's fine. I'm not worried about that. But do you see how this problem can be confusing if you just look at their directions? I may be wrong, but that problem looks confusing just from the get-go, but it's not. And if you plug in, just so y'all know, if you plug in negative 2 times parentheses, sine of parentheses squared, plug in pi over 2, you're going to get negative pi sine of pi squared over 4. And I think that's what they got. Is that a test question? No. I wouldn't put that on the test because it could confuse you. Does everybody see what I did when I took the parts and I did that? Do you see what I'm saying? It can be very confusing if you just look at it like that. Next one. Please, let's do a good question. A good derivative question. Well, this one's not too bad. Find the cotangent. First of all, you go to your handy dandy sheet. Write down the cotangent. If you don't know it, if you don't have your sheet, there it is. So the cotangent, or is that cotangent or is that inverse cotangent? Hold on. No, it's not inverse cotangent. It is, what is it? It's cotangent. And you go to File, for those of you that hadn't got the cotangent. And it's pretty much secant squared. What is it called? Derivatives of inverse or derivatives? There it is. Trig derivatives. And what's the derivative of cotangent? If it ever comes up, secant, cosecant squared. Negative cosecant squared, so write that down. Negative cosecant squared is the first thing you write down. So y is equal to the cotangent of 5x dot e to the x. And we know that the derivative of the cotangent is the negative cosecant squared. So the first thing we do is we write down y prime is equal to negative cosecant, and I can't put an S. I'm just worthless today. Negative cosecant squared of 5x e to the x, and then we're done, right? Right or wrong? We're done.
Wrong.
First
Wrong.
times the derivative of the second plus the second times the derivative of the first. What am I doing? I'm taking the derivative of what?
The inside function.
What's inside? Five x e to the x plus 5e to the x. And that's pretty much it. You could take this and put it out front, but that's about it. So you could do negative 5x e to the x minus 5e to the x cosecant squared of 5x times e to the x. That's an okay test question. And there's several different things you could do down here. You could factor out a 5e to the x right here. I don't think they'd want that, but that's good enough for government work. You could actually distribute this cosecant squared 5xe to the x with each one of these. You could do that. So that's good enough for government work. Next,
It's
31024.
310 right now, just like you know.
Oh, it is.
Yeah.
And finally, this is the first good test question we've actually come to. Go ahead and do it. We'll take our remaining 4 minutes. Get one good test question out of all those. I can see why people fail calculus, chasing after rabbits like some of these questions. It's ridiculous. All right, f of x is equal to x over x minus 6. How do we find the inverse function? What do we do first?
Swap the variables.
Well, we got to write f of x as y and then swap the variables. You're right. So y is equal to x over x minus 6. X is equal to y over y minus 6. Multiply both sides by y minus 6. And right now, we're just doing algebra. So that's going to be x times y minus 6 equals y. That pen's going in the garbage. And that's going to be xy minus 6x is equal to y. And I got to get all my y's, so I'm going to bring the y over and take the 6x across the river. So that would be xy minus y is equal to positive 6x. Factor out a y, x minus 1 is equal to 6x. And y to the negative 1 is equal to 6x over x minus y. Now what? They want you to take the what?
Derivative.
Take the derivative of that. So denominator times numerator prime minus the numerator times denominator prime over the denominator squared. And that's going to give you y to the negative 1 prime is equal to x minus 1 times 6 minus 6x times what? Over x minus 1 quantity squared six x minus 6 minus 6x over x minus 1 quantity squared. And hopefully I ain't going to get too elimination happy like I did the other day. And there is your derivative. Negative 6 over x minus 1 quantity squared. That is a test question. That is a concrete algebra calculus question, not finding out how many people went to Wimbledon and not what were their addresses, not stupid directions, not out of left field. This is a bare basic calculus question. Heaven forbid. All right. You got 24 hours to finish the test and get there. And you got till 12 o'clock tonight to get some of this homework. And 8 or 9 of you, I don't know what you're going to do because you haven't even started. So I don't know what. I ain't going to lecture. Who's got questions for me?
So, is the test due tomorrow by class time? Is that when it's due?
Say it again, Mr. Lee Croy. I couldn't hardly understand you. What'd you say?
Is the test due tomorrow by class time?
Midnight.
Oh, by midnight. Okay. I thought it was by class time. Okay, thank you.
Yeah. And the homework, I think, is due tonight by midnight, right?
Yeah, that's correct.
Because you got 24 hours, because I gave you till today to finish up your homework. So you're welcome. All right, y'all get out of here and have a good day. Unless you got, I got to do attendance. Hold on, let me do that. I keep forgetting. And Tri-County hopefully has not logged me out. But I'm not going to speak too soon.